Today we're on page 1 of our Chapter 12 notes packet. Now, Chapter 12 will be working with several different formulas, and these formulas are given to you. All right, they are found on the reference sheet for the Algebra 2 trig. So I have here a copy of the Chapter 12 notes packet, and also I'm bringing in the Algebra 2 trig reference sheet here. Okay, so you can see on the reference sheet, we're going to be working with today, starting with the function of the sum of two angles and the function of the difference of two angles. All right, so we're working with these two groups. And then later in this chapter, we'll be working with the function of a double angle and the function of a half angle. All right, so sometimes, although these are already typed out for you within the Chapter 12 notes packet, sometimes I'll refer to them as being in the packet. Other times I'll just take this reference sheet and get them off the reference sheet. Okay, that'll save me some flipping back and forth, I think. All right, so first we're starting with the sum and difference of two angle formulas. Sometimes you'll be working with two different angles, often our special angles. That would be any multiples of 30, like 30, 60, 90, 120, 150, and so on, or 45, 45, 90, 135, 225. To find the exact values of sine, cosine, and tangent of a third angle. All right, so when we're finding exact value, what comes into play here? Everything we learned back in chapters 9 and 10. All right, we'll have to remember the trig table. We'll have to remember our signs, S-I-G-N-S. All students take chemistry, all that good stuff. You'll be asked to find the sine, cosine, and tangent of their sum, right? The sum of two angles, sum of A plus B. A represents angle A and B, capital B, represents angle B. And or the difference of A minus B. You use the formulas to find the sum or difference. You will not distribute trig functions into a parentheses. In other words, the sign of A plus B does not equal, you do not distribute. It does not equal the sign of A plus the sign of B. Right? Absolutely not. The following formulas are given to you on the reference sheet, as I pointed out. They do not need to be memorized. Yay! Don't have to memorize these. Okay, so here we have the function of the sum of two angles. The sine of A plus B is going to equal the sine of A times the cosine of B plus the cosine of A times the sine of B. The cosine of A plus B would equal the cosine of A times the cosine of B minus the sine of A times the sine of B. Then we have the tangent of A plus B is equal to this formula, sine A plus sine B, divided by 1 minus this tangent. Oops, sorry, I said sine when it should have been tangent. The tangent of A plus B is equal to the tangent of A plus the tangent of B, divided by 1 minus the tangent of A times the tangent of B. And then we have the function for the difference of two angles. Okay, and again, I'm going to refer to they're also on the reference sheet here. Okay, here's the sum of the two angles and the difference of two angles. All right, well, why do we have to know this? Well, what if we want to find the exact value of something like the sine of 15 degrees? Right now, we only can find exact values of angle measures of 30 or multiples of 30 or 45. Okay, so the 15, how can we come up with 15? Well, what if we took 45 minus 30? If we took the sine of 45 subtract 30, that would be equivalent to the sine of 15. So this is where it's going to come in. All right, so starting off, just a little bit of practice here. before we actually address and look at the sine of 15 degrees on the next page. We're up to tangent here. Now, often it is easier to use the tangent of A plus or minus B is equal to, remember, tangent is equal to sine over cosine. So we could simply substitute it with the sine of A plus or minus B over the cosine of A plus or minus B. First, we're going to complete the identity. And remember, an identity is an equation that is true for all values of the variable. We have the sine of x plus y. Well, this is simply the same as the sine of A plus B. So we go up to our formula above, all right? And in place of A, we substitute x, and in place of B, we substitute y. So this is going to equal the sine of x times the cosine of y plus the cosine of x times the sine of y. Just substituting x in for A and y in for B. Next, let's find the sine of 300. Now, 300 degrees is equivalent to 270 plus 30. All right. Now, I know you know how to find the exact value of 300. All right. Let's just recall. So what would we do? We would actually draw the angle of 300 degrees. So using our old way of finding the sine of 300 first. What's the reference angle? The reference angle is 60. So the sine of 300 degree angle is in quadrant 4, where sine is negative, right? All students take chemistry. Sine is negative. So this would be equivalent to negative sine 60. And now using our trig table, okay, I think I'm going to write this off to the side here, our trig table. 30, 45, 60, sine, cosine, all over 2, 1, 2, 3, 3, 2, 1. So the sine of 60 is equivalent to the square root of 3 over 2. So this is equal to negative square root of 3 over 2. Now, our new way, using our formula, the sine of 270 plus 30 is the sine of A plus B. This is going to equal, getting it from the formula above, sine of A plus B is equal sine A cosine B, sine A cosine B, minus sine A, oops, sorry, look, my eyes wandered and went to the wrong one, plus cosine A sine B, plus cosine A sine B. Okay, so we substitute, we replace A with 270. So this is going to be the sine of 270 degrees. And we replace B with 30 degrees times the cosine of 30 plus the cosine of 270 times the sine of 30. Now, what's the sine of 270? 270 is a quadrantal angle, right? 270, be here, coordinates 0, negative 1. Sine is the y value, so that would be negative 1. Cosine of 30, go over to our trig table. Cosine of 30 degrees is square root of 3 over 2. Right. Plus the cosine of 70, that's our x value, 0, and the sine of 30. Over to our trig table, sine of 30, square root of 1 over 2. Square root of 1 is 1, so that's simply 1/2, but we're multiplying by 0, so that's just going to result in 0. Negative 1 times the square root of 3 over 2 is negative square root of 3 over 2, plus 0 is simply negative square root of 3 over 2. So our new way, of course, answer came out to match our old way. Next, the cosine of negative 2 pi over 3. Okay, negative 2 pi over 3 is equivalent to 1 pi over 3 minus pi. That's 1 minus 3 is negative 2. So we get negative 2 pi over 3. All right, so this is the cosine of a minus b. Cosine of a minus b, we look up at our formula. Cosine of a minus b is cosine a cosine b plus sine a times sine b. So let's make our substitutions. Let's just I'll write up here, that's equal to the cosine of a times the cosine of b plus the sine of a times the sine of b. Cosine of a. A is pi over 3. So this is the cosine of pi over 3 times the cosine of b is pi plus the sine of pi over 3 times the sine of pi. Okay, pi over 3, that's equivalent to, this is radian measure, so times it by 180 over pi, so that's 60 degrees. So this would be the cosine of 60 degrees times the cosine, and pi is equivalent to how many degrees? 180 plus sine 60 times sine 180. Okay, cosine of 60 degrees. Look up at our trig table, cosine of 60, square root of 1 over 2, or simply 1/2. So we're replacing cosine 60 with its value 1/2. Cosine of 180, looking at our quadrantal angle, 180 degrees, unit circle. Coordinates would be negative 1, 0. Cosine is the x coordinate, so that's negative 1. Plus the sine of 60, just look up at the trig table. Sine of 60 is square root of 3 over 2. Times the sine of 180. Sine of 180 is 0. So we have negative 1/2 plus 0, which is simply negative 1/2. Next page, we want to find the exact value of sine, cosine, and tangent of 15 degrees by using the formulas. Okay, so here we have the sine of 15 degrees. Well, 15 is equivalent to 60 minus 45. All right, so this is the sine of a minus b. Looking at our formulas, the sine of a minus b is here. Sine a times cosine b minus cosine a times sine b. This is going to equal sine a times cosine b minus cosine a times sine b. And now we'll simply replace a with 60 degrees and b with 45. So we have the sine of 60 degrees times the cosine of 45 degrees minus the cosine of 60 degrees times the sine of 45. And I think up here I'll just copy over our trick table. Square root of 30, 45, 60, sine, cosine, all over 2. 1, 2, 3, 3, 2, 1. Okay, so the sine of 60, square root of 3 over 2, times the cosine of 45, square root of 2 over 2, minus cosine of 60, square root of 1 over 2, which is simply 1/2, times the sine of 45, square root of 2 over 2. Okay, square root of 3 over 2 times square root of 2 over 2 is square root of 6 over 2. No, 4, right? We're multiplying. Minus 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. Same denominators. Copy the denominator of 4. And the square root of 2, or sorry, the square root of 6 minus the square root of 2 is just that. The square root of 6 minus the square root of 2. That's our answer. Okay, now we could check this. Let's check. All right, go to the calculator and let's make sure we're in degree mode for this. And if I take the sine of 15 gives us that decimal. And if I take the square root of 6 minus the square root of 2, all divided by 4, we get the same decimal. So our answer is correct. Next, we want the cosine of 15 degrees. The cosine of 15 is equivalent to the cosine of 60 minus 45. So cosine of A minus B, we're looking at that formula. All right. Cosine of A minus B, cosine A times cosine B, plus sine A times sine B. So this is equal to cosine of A times the cosine of B, plus sine A times the sine of B. All right, now we substitute 60 degrees in for A and 45 in for B. So this is going to be the cosine of 60 times the cosine of 45 plus the sine of 60 times the sine of 45. Cosine of 60, looking at the trick table in your upper right-hand corner that you have copied down. Cosine of 60 is 1/2. The cosine of 45 is the square root of 2 over 2. The sine of 60 is square root of 3 over 2. And the sine of 45 is the square root of 2 over 2. Multiplying, 1/2 times the square root of 2 over 2 is the square root of 2 over 4. Plus square root of 3 times square root of 2 is square root of 6. Over 2 times 2 is 4. Same denominator, this is a 4. So this is equal to square root of 2 plus the square root of 6 all over 4. Now the tangent of 45, or sorry, the tangent of 15. Tangent of 15 is tan 60 minus 45. Looking at tangent, we could do two ways. Since we already have the sine of 15 and the cosine of 15, we could say that tangent is equal to sine over cosine. So it could equal sine of 15 divided by cosine 15. All right, so we take our two values from above, the square root of 6 minus the square root of 2 all over 4, divided by the square root of 2 plus the square root of 6 all over 4. All right, since these denominators are the same, they can just divide out, and we'll be left with the square root of 6 minus the square root of 2 all over. I'm just going to write the square root of 6 first. The square root of 6 plus the square root of 2. Okay, we would still have to rationalize that denominator. We would do that by multiplying by the conjugate, the square root of 6 minus the square root of 2 over square root of 6 minus square root of 2. Okay, now foiling here. Square root of 6 times square root of 6 is 6. The outside would be negative square root of 12. And the inside would also be a negative square root of 12. So that'd be negative 2 square root of 12. And negative square root of 2 times negative square root of 2 is positive 2 all over. And since these are conjugates, that would simply be 6 minus 2. Reducing, we have 8 minus 2 square root of 12. And yes, we'll have to simplify the square root of 12 all over 4. And 12, I'm thinking 4 times 3, and the square root of 4 is 2. So 2 times 2 is 4, so 8 minus 4 square root of 3 all over 2. And then, all over 4. And then reducing, dividing each by 4, we end up with 2 minus the square root of 3. Okay. Now, the other way of doing it is to actually use the formula, right, for tangent of a minus b. The tangent of a minus b is here. It's tan a minus tan b over 1 plus tan a times tan b. So this would be tan a, just going to write it down, tan 60 minus tan 45 over 1 minus tan 60 times tan 45. Right. And now tan 60, tangent of 60 is square root of 3 over 1, so that's the square root of 3. Tangent 45 is 1 all over 1 plus tan 60 is that square root of 3 times 1. That's going to be square root of 3 times 1 is simply square root of 3. And then we would have to rationalize this by multiplying by 1 minus the square root of 3 over 1 minus square root of 3. Okay, so this is going to be 1 minus 3 plus 2 square root of 3 all over 1 minus 3. So we have negative 2 plus 2 square root of 3 all over negative 2, and dividing. Oh, sorry, that was a negative 1. So this was a negative 4. All right, and then dividing each by negative 2, we come out with the same, positive 2 minus the square root of 3. Okay, hopefully I can do the next one a little quicker. We want to find the sine of 165 degrees. All right, sine of 165 degrees. Well, 165 is equivalent to 30 plus 135. Okay, so this is going to equal the sine of 30 plus 135. So this is the sine of a plus b. So looking at the I'm going to the reference sheet. If we flip back to the other page, the sine of a plus b is sine a times cosine b plus cosine a sine b. So the sine of a, sine 30, times the cosine of 135, plus the cosine of a, cosine 30, times the sine of 135. Okay, sine of 30, no problem there. That's 1/2. Now the cosine of 135, 135 degree angle is in quadrant 2, right? So if I go off to the side here, draw 135 degrees. Reference angle is 45 degrees, right? And in quadrant 2, cosine is negative, so this would be equivalent to negative cosine of 45. And the cosine of 45 is the square root of 2 over 2. So this would be negative square root of 2 over 2. Cosine of 30, square root of 3 over 2, times the sine of 135. The 135 degree angle in quadrant 2 has the reference angle of 45, and sine is positive in quadrant 2, so that would be simply equal to the sine of 45, which is the square root of 2 over 2. Multiplying, those would be negative square root of 2 over 4 plus square root of 6 over 4, which would equal negative 2 plus the square root of 6. I'm just going to write the square root of 6 first. So square root of 6 minus the square root of 2 all over 4. Next, the cosine of 165 degrees. 165 can be written as a sum of 30 and 135. So this is the cosine of A plus B. And look at the formula. The cosine of A plus B is equal to cosine A cosine B minus sine A sine B. So this would be cosine 30 times the cosine of 135 minus the sine of 30 times the cosine of 135. Nope, that was sine. Sorry. Cosine of 30 degrees, cosine. Again, I'm going up to the trick table that I've got in the upper right-hand corner there. Whoops, there we go. Cosine of 30, square root of 3 over 2. Cosine of 135, all right. We have it from above, that's negative square root of 2 over 2, minus the sine of 30 is 1/2, and the sine of 135 is equivalent to sine of 45, which was the square root of 2 over 2. This is negative square root of 6 over 4, minus the square root of 2 over 4, is equal to, same denominator, copy it, negative square root of 6 minus the square root of 2 all over 4. And for the tangent of 165, okay, I'm just going to take sine over cosine. All right, so it would be the sine of 165 over the cosine of 165. Sine of 165 is our square root of 6 minus the square root of 2 all over 4. And then the cosine, negative square root of 6 minus the square root of 2 all over 4. Okay, the denominators are the same there. They'll just divide out. It's the same as multiplying by 1 in the form of 4 over 4. So we have the square root of 6 minus the square root of 2 over negative square root of 6 minus the square root of 2. And yes, we would have to rationalize this denominator by multiplying that by the conjugate of the denominator. Negative square root of 6 plus the square root of 2 over negative square root of 6 plus the square root of 2. And at this point, we're getting quite long in the video, so I'll just kind of go through this quickly. We're going to have 6 plus the square root of plus 2 square root of 12 minus 2 all over negative 6. Oops, we're multiplying, so that'll be positive 6 minus 2. So this would be 4 plus, simplifying the square root of 12, 4 times 3, so that's 2 times 2, 4 square root of 3 all over 4. And these 4's divide out. Let me change this here. I'm sorry, I know I'm getting long in the video, so I'm rushing through and I'm missing my signs. This would be -8. And dividing by 4 finally, -2 plus the square root of 3 is our final answer. Thank you very much.